hexapods. They come in a multitude of different sizes and configurations. I've always been very interested in robotics, so hexapod has always been quite high on my to-do list. In this video, I'm gonna show you this, the leg design. So without further ado, let's get started. A hexapod, as the name suggests, has 6 legs. Each of those can have 2, 3, 4 or more servos. Like most designs out there, I settled with 3 joints for each leg, meaning I would need 18 servos. That can get expensive very fast, which is why I decided to use these MG996R servos. Supposedly, they can provide 13 kilograms per centimeter or about 1.3 newton meters of torque, but that is most likely an overstatement. I tested the 18 servos I bought, and boy is it a good thing I did. 3 of the 18 were just not working. To drive the servos, I'm using a PCA 9865 driver. With the accompanying Adafruit library, this allows me to control 16 servos per driver using I2C. Designing the leg, I wanted to avoid any external cable harness. This ended up looking very good, but made repairing the leg pretty much impossible without disassembling everything. I also designed my part a bit different to most other builds out there, by modeling the servos as an integral part of the structure. This saves me space and plastic. It also means I have to disassemble each servo. I used this opportunity to properly loop the gearbox and bushings. If you buy these new, it is quite common for it to not be properly looped, especially for this bushing that leads to excessive wear. Starting off with these 2 pieces, which will attach to the main body. Next we have these 2 plates and this servo mount, which together will form the trochanter. Following that, there are 2 servos and 1 3D printed piece which form the femur. Finally, there are 4 3D printed pieces that form the tibia of the leg. I made sure to design the tip as a separate piece in case I want to print it in flexibles or maybe add some sort of foot sensor in the future. With the first design in mind, let's get to printing. This is version 1 of the leg. We have these 2 servos moving the leg up and down, and the third one right here that's gonna articulate the leg and forth. There are gonna be 2 plates on the top and bottom that are gonna clamp onto the servo and hold it in place. And it can move kind of like this. There are a bunch of places where I can improve the design, and one of them is right here. This part is a bit too thick. I don't really like this U shape. It takes a bunch of screws. there are some places like right here that are a bit tricky to print. And yeah, so I'm gonna improve the design, see what I can come up with, and I'm gonna see you in a minute. So this is what I came up with for version 2. It's a lot smaller, uses far less screws, and I think also looks a lot better. Especially like how the front looks. And I'm really happy with the design. I think I'm gonna use it for the final version. Also ignore this white piece, the final version is gonna be all black, and I'm really excited how the final version is gonna look. So I only need to make 5 more of these. I also built a final version with cable management, and it's a good thing I did, because it did not work at all. My design wants to bend the cables, and that can work fine, if you give them enough room. I don't want to have big cable loops, so what instead of bending it, we twist it. I can route the wires through the bearing and along the femur. In addition to these changes, I added 31 addressable RGB LEDs. These should look awesome. After making the changes, I could print the final version. Now that we have a leg design nailed down, how do we control it? Well, we could go in and set the value for each servo manually. This is called forward kinematics and it's by far the simplest solution. But for an hexapod that is not really an option. It is very static and programming a proper walking gait would be next to impossible. Instead, most hexapods use something called inverse kinematics. Basically, we tell a magic algorithm of sorts where this endpoint should be, and it then calculates the necessary angles for each joint. I'm not going to go into detail on how to do that exactly, because there's a great video out there from just another maker channel. His design is a bit different because these two joints don't really align in my design, but for the most part the same equations apply. After I got the formulas, I only had to translate them into code. Once I got it moving, I noticed a new problem. It seems that the servos are constantly overshooting and overcorrecting. They are just not built with this kind of inertia in mind. My solution is quite simple. Instead of using a bearing, I can simply use a bushing. By controlling the fit, I can add just enough resistance to remove it completely. After all that, let's see if my idea of adding 31 addressable LEDs to each leg was even a good idea. And yes, it was all worth it. In my opinion, it looks awesome. And that wraps up this video. I hope you enjoyed following along. In my next video, I'll be delving into the construction of the body, so subscribe if you don't want to miss it. If you're interested in replicating this project or maybe just exploring the details further, you can find everything in the description down below. This will include things like 3D models, code, schematics, and a full parts list. At least once I'm done. Thanks for watching, and we'll hopefully see you next time. They come in a... God. Can have 3, 2... Comes down, setting constant, drawing triangle, and a whole bunch of math.